Hey guys, how are you doing? Today we're going to see how to solve unique paths problem. So let's jump into the problem statement. Given m into n grid like this, and there's a robot which is ready to travel from first cell to reach the last cell, right? So it has two choices. Either it can move towards right and make the path, and it can move to the bottom. By making such choices, we need to find all the possible paths to reach the last cell of the grid. All right, hope you're clear with the problem statement. Let's see how do we solve this problem using various approaches. In order to solve this problem using the recursive approach, let's assume that the robot is actually traveling from finish cell to the start cell. When we start to make our very first recursive call uh, from the first cell, that is 0, 0, we will start the call from here, and at the end of the execution, we have to return the result from here, right? So to calculate the result of the first cell, we need the number of unique paths available from the right, and we need the number of unique paths which is available from the bottom. So number of unique paths to the right cell from finish, and number of unique paths to the bottom cell from finish. So when we know these two values, we just have to add those two values and just return the result like that. Okay, let's start to calculate the values of each node. Let's say we start from the right bottom cell, and this is just a base case for us for our recursive function. So if we start from the first node, we eventually reach the bottom cell, right? So making the recursive call, choosing the right and choosing the bottom, and eventually we'll reach the last cell. So if we hit the last cell, the result of it is just we can just return 1, because from finish, from the last cell, if we reach itself, the path to itself is 1. So we just have to return 1. And if we are not at the last cell, for example, we are at some other cell, then we need the same calculation as the first cell, right? So it needs the right source, number of unique paths from the right and number of unique paths from the bottom. Let's calculate the number of unique paths for the other cells. For example, uh, for this cell, the number of unique paths from finish is just 1, right? It can be reached by this. And for this cell, it is just 1, right? So from finish. And for this cell, it can reach this cell from finish from either through this path or through this path. There are two different paths, right? So just we can just add these two values. Okay, so number of unique paths to reach this cell from the finish is just 2, and we fill this value. Number of unique paths to reach here is just 1 from right, and there is no bottom, so hence 1. And we start to calculate, okay, from here I can reach a cell, so that is one path, and from here I can have two other paths, either to choose this one or to choose this one. So we just add these two values and fill this up. And finally, we are going to return this answer as our result from the recursive function, all right, where we have started. Let's look at the recursion tree for this example. We are starting from the first cell. We are making recursive calls to the bottom cell and the right cell to find the answers. You can see that we are making some repetitive calls here. This subtree and this subtree in the recursion tree is actually being repeated. This has been already calculated as part of this call, and as part of this call, it is being again called, right? So consider this as a subproblem. So there could be many subproblems we will be solving again and again. So this is exactly called the overlapping of subproblems. So along the recursion execution, right? We can avoid the duplicate executions of subproblems by storing their results in the cache memory. If we detect that this call is already being made, we can easily retrieve it from the cached memory. This process of storing the subproblem results in a cache memory is known as the memoization. We can only store the return values of a subproblem in the cache memory with the given inputs. So using the input parameters, we will be able to easily retrieve the result of that particular call instead of making the recursive call to execute again, right? Okay, let's see how do we code this. Let's design a recursive function. Let recur equal to, it accepts two indices, which will be used to traverse, right? So let's start to write the base cases here. So if we are making a call that is falling beyond the grid, like beyond the number of rows, right? So I is exceeding the number of rows, or the j exceeds the number of columns, just return 0. Okay, there could be no possible paths available from the empty cell or the invalid cell, right? So this is one case, and if we reach the the last cell, we have to return just one, right? So to reach the last node by itself is just one, and we need to calculate the results from the right and results from the bottom. So from right equal to recur. What is the right index? So we are moving to right, right? So the same row with the column increased. So we are moving to the next column basically. And let from bottom equal to recur. So next row with the same column. And we have to just return the result by adding those values, right? So return recur 1 1. We are starting from the first cell and we are reaching till the last cell, right? So let's test this. It works, but if you see, it will take the huge time, the time limit will exceed because the runtime is very huge. So the time complexity of this solution is exponential, right? So if you see that one recursive call emits two other calls, right? And that particular call again emits two more calls. So the worst case, it can go up to 2 power maximum of row versus column, right? Now let's talk about the dynamic programming approach. We know that we have to add the values from the bottom cell and the right cell. So for that, in the last approach, we have to make recursive calls to get the answers. In this approach, we are going to eliminate the recursive calls and start to calculate the values of each cell. So for each cell, we are not going to take the values from the right or bottom. So instead, we're going to calculate the values from the left and the top, right? So we have to reach one particular cell and we have to calculate the values from the top, and because we start from the first cell and we calculate till we reach the last cell. Dynamic programming problems mostly rely on the facts that may or may not be specific to the problem statement. Here, the fact is, in order to get the answer for the current cell, we need to add the values from the sources, that is right and bottom, or the left or top, right? Based on the traverse we do during the execution of our solution. So let's have similar sized 2D array to store our values. We know the fact that each cell in the first row can be reached only by the cell to its left, right? Hence we have the value as 1. So to reach this cell, that the source is only from the left, and we just have the value 1. And to reach this cell, just from the left, that's the only path, right? So we just fill the value 1. So similar calculation for the first column, because each cell in the first column can be reached only by the cell on its top, right? So we have the initial pre-calculated values. So from these pre-calculated values, we can easily fill up the whole 2D array using this expression, right? So when we reach this, so we start from 1, and this we just start from 1, and to calculate this cell, we'll take the value from its previous cell to its left, that is j minus 1, and the cell from the top, that is the previous row, right? So I minus 1. So the current cell can be filled by adding up these two values, right? At the end of the calculation, we have our last cell filled with the answer for our problem. And this has a time complexity of m into n because we need to traverse each and every cell, and space is the just whole DP array. Let's try to implement this. So I'll remove this. So let's design a DP method function here. It accepts m and n. So So we have to declare a 2D array to store the values. Let's call it as dp array of size m, and for each item in that, let's say dp of I equal to new array n, and which is filled with 1, right? So initially it will be filled with 1, meaning the whole matrix is filled with 1, right? So let's start to calculate the intermediate values. So let's start with 1 because we have already calculated the first row and the first column. We are filled with 1 and we have to omit that. So we just ignore calculating them. And let's say the column starts with 1 and goes till the end element, goes till the last row. And so we just have to calculate the current cell's value using the expression uh, dp of I of j equals that the previous value, that is I j minus 1 plus the value from the top, which is I minus 1 of the current column, right? So this is a value. After calculating, just we can return dp of m minus 1 and n minus 1. So the last cell will eventually have that result for us, right? So we can just, so instead of this recursion method, we can just say dp method of m comma n. Let's test this, right? Let's try to submit this. So this dynamic programming solution takes the huge space. The whole grid is actually stored in the memory. So let's see how do we optimize the space. So if you closely notice that in order to calculate the value of each cell, we need to have the reference of the previous row and the current row. That is, the current row is required only to refer the previous value, and the previous row itself is required to have to access the value from the top, right? So we don't need the whole 2D array in the memory. So we just have to store the previous and the current row. So let's see how do we change implementation to store only the 2 rows. So instead of having the DP array, so let's declare previous equal to new array of n because we want the number of columns, right? So that will be filled with 1, and let's say current equal to just previous. Okay, we're going to update the current anyway. So instead of updating the TP array here, let's say current of j equals to the current value of j, right? So sorry, j minus 1, right? Plus the previous row's j, correct? So we are actually calculating the current row, and we have to make the current row. After calculating the current row, we have to make the previous row equal to the current row. All right, and we have to return the current row of n minus 1. So just like the TP array had our answer in the last cell. So we are keep tracking the current row, and the current row's last cell has the answer. So let's test this. All right, let's try to submit this. So we can also optimize this further by eliminating the previous row, tracking the previous row, because if you notice that the current row will become the previous row for the next iteration of j, right? So let's try to get rid of this. So instead of previous, we have only the current, and we eliminate this. And instead of accessing the previous of j, because at this calculation, before this calculation, the current of j will be the previous row, right? So we are just updating the same row again and again till we reach the last row, right? So for the next iteration for the next row, the current row will actually become the previous. So we can just eliminate the previous usage as well. So let's try to submit this. You can also think that we can just eliminate the current row itself. We can just have just two values to keep track, and we can just update here because we are just relying on two variables only, right? The source from the top and the source from the left. So if we think in that case, after completing the current row, the previous value will be this, and the current value will be resetted to this, right? If we are processing this, we have two variables. Let's see. The previous will be 10 and the current value will be 1. And if we are trying to calculate this, we will lose the actual previous, actual top. So we need the entire row to be in memory so that we have to take the corresponding top value to retrieve. So you are basically overwriting. If you use two variables only, maybe the current value can be tracked properly, but you will lose the previous values because all we need is the corresponding top, right? So that could be taken care by storing the whole row in the memory. Okay, all right. Hope you enjoyed this video and please subscribe to see more videos like this. And thanks for watching.